The name of this section is Solving Quadratic Equations by Completing the Square. So we've already done this by graphing a bunch of different ways, but now we're going to find out this new thing called completing the square. And when you have rational roots, we have an example problem here where it says solve x squared minus 10x plus 25 equals 7 by taking the square root of each side, round to the nearest tenth if necessary. Now this doesn't mean that we just slap square roots there and move on. And it also doesn't mean that we subtract 7 from both sides yet. We're sort of being lobbed a softball by being told to take the square root of each side, and on a problem like this, normally it might work out to be more challenging, because you'd have a lot of independence and planning ahead that would have to happen. So looking at the left side and totally ignoring the right, can you factor this? So x squared minus 10x plus 25 does factor nicely. It's a perfect square, so I'm going to write x minus 5 squared is equal to 7. And since my variable is in parentheses and I only have a number on the right and no variables over there, I can now square root both sides. What this means is that x minus 5 is what I'm left with because I take the square root of something, like 3 squared, which is 9, I would get 3. You're always going to end up with what you began with. So when I take the square root of something that is squared, the only thing that would remain is that x minus 5 chunk. And that will be equal not just to the square root of 7, but to positive or negative 7. X minus 5 equals positive or negative 7. I still don't have the variable by itself. And to do that, I'll add 5 to both sides. Notice that 5 wasn't a part of this plus or minus deal. 5 is just going to be positive. So when I move it down and I write x is equal to all this stuff, the convention is to write 5 first, plus or minus the square root of 7. Now that is exact, but since they say round to the nearest tenth, we are going to type that into the calculator to give us an idea of where these roots are at. So 5 plus square root of 7 is going to give you something, and then 5 minus the square root of 7 is going to give you something. And we're going to round to the tenths. So that would be x is approximately 2 4/10 or 7 6/10. And just to plan for the future, this is going to be the more common way that you'll see these written, because it's more challenging and it's also exact. While this is kind of the training wheels method right now. And the good thing about this is, by writing 2 4/10 and 7 6/10, you really do have a more clear picture that it's between 2 and 4 on the graph. 2 and 3 on the graph. Solve m squared plus 18m plus 81 equals 90 by taking the square root of each side. Okay, I want you to try this on your own and then come back to the video. The assumption is going to be that this factors nicely if they're giving us these instructions. So a few more seconds and I'll put the results up. So looking at this, we have the original problem rewritten, and then that factored nicely to give us m plus 9 squared. Once we had m plus 9 squared, we could take the square root of both sides, and we wouldn't turn the square root of 90 into a decimal. I know that I can take the square root of 81, I know that I can take the square root of 100, but I can't take the square root of 90, but in the next chapter, we'll get more into that. We'd subtract 9 from both sides. We knew that this has to be plus or minus, and this is the conventional way to write it. And I'm not sure how you feel, but this seemed a little bit outlandish to me. And remember, you could always type this into Wolfram Alpha and check out to see if the original equation gave you these values. Also, if you just wanted to do a quick check, you could look at your problem and say, well, this is negative 9, this is about 9, and so negative 9 minus 9 would be negative 18, or you could be like negative 9 plus 9, in the case that it was positive. It's pretty close to a half. So it seems reasonable. It's not totally outlandish. Now that means you only did one OYO example, and then quickly demonstrated this after walking through one with the teacher guide. Now check this out. Let's say you would have approached this thinking, well, I want to get everything solved to one side. Subtract 90 from both sides. M squared plus 18m minus 9 equals 0. And you'd be like, well, what are the factors of 9 that add up to 18? And well, that's kind of a dead end. But then maybe you'd be told to do this by completing the square or something else through methods later. So we're going to see what that looks like. Not in this video, but in later ones. So this is a short one, but that doesn't mean that these are simple problems. So make sure that you give yourself enough time to process this and figure out how to do it with all the other ones combined.